for to this one unique number. Hey guys, so here we are with the first question. Using Euclid's division algorithm, we need to find the HCF of 135 and 225. Now, Euclid's division algorithm, just a quick recap, says that A is equal to BQ plus R. Now, what is it? It says that if you have two unique numbers, let's say A and B, okay, such that A is greater than B, and if one divides A with B, we get two unique numbers upon dividing, which is Q and R, where Q is quotient and R is the remainder. So how and what is the relationship between AB, Q and R? This is what Euclid's division algorithm tells us. Okay, having said that, let's quickly begin. So this is the algorithm. Now, which number is bigger? Of course, 225. So 225 is our dividend. If one divides 225 with 135, what is the quotient? It will take away 225 one times, and the remainder that you will get would be 90. Check that. Okay, and see, I'll just do this one division for you so that you can go ahead and relate it. So 135 will take away 225 one times, right? That's the highest quotient that you can get here, and in return we are left with 90 as the remainder, isn't it? So this is what I've written. 90 has taken the value of R. 1 is nothing but the quotient. 135, yes guys, it is the divisor, and 225 here is our dividend. Okay, so similarly, now what we spot here, that we got the remainder as 90 and this was our divisor. So now these become the next values of A and B, and they continue unless we hit with the remainder 0. So now when 90 divides 135, 90 will again take away 135 one times, quotient, plus the remainder that we'll be left with is 45, isn't it? Now what are the remainders and the divisor? It's 90 and 45. I hope you can easily divide 90 with 45, and you know what, 45 will evenly take 90 two times, giving back the remainder 0. So yes, this is it. Dead stop here when you get the remainder as 0. When we hit the remainder 0, it means that the HCF is found. And what is the HCF? The HCF at this stage is the divisor itself, which is nothing but 45, right? So 45 is the HCF. For the second problem, we repeat the same process. So since 38,220 is bigger, if you divide that by 196, so 196 will take away this number by, if you are up with your calculator, you will see that it will perfectly take it 195 times, giving back you the 0 remainder. So yes, what was the immediate divisor when one hits the remainder 0? What was the immediate divisor? It was 196. So yes guys, 196 is our HCF for the second part. Let's solve the last one here. Last one here has the numbers 867 and 255. So dividing 867 with 255, 255 will take away 867 completely 3 times, isn't it? 3 times, and would give you back the remainder 102, right? So we don't stop here because the remainder is non-zero. Again, what are the remainders and the divisor? I've underlined them. So we repeat the process. Now 255 will get divided by 102. 102 will take away 255 2 times, just 2 times, and giving back the remainder 51. So we don't stop here because the remainder is non-zero. We continue with the following divisor and remainders. Now they instead become the new dividend and the quotient. So 51 will take away how many times? 102? Yes, exactly. Perfectly 2 times, isn't it? Giving you back the remainder 0. That's it. We stop here. And what was the immediate divisor? It's 51. So therefore, we say 51 is the HCF for these two given numbers. I hope you got this, guys.